Okay, let's get into this. We are doing a deep dive into some documentation that, honestly, very few people ever get to see. But it's kind of the secret ingredient behind every single massive, successful engineering and construction project.
It really is. We're navigating the foundational structure, the digital backbone of these mega projects. And this isn't about pouring concrete or welding steel. It's about how the entire digital record of that physical asset gets created, managed, and, preserved for decades. That record, in the long run, is often way more valuable than the asset itself.
And our source for this is super specific. It's an employer requirement document, E2.Asian, that deals purely with information management. That's IM and information technology, IT. For you, the listener, this document is basically the shortcut to understanding what operational readiness actually means. It's the difference between a facility that just, turns on and one that can actually be maintained and optimized for the next 30 years.
And that is the absolute core mission of this deep dive. We need to translate these complex procedures and plans. But the most important thing is to understand the strategy baked into this document. Why are IM and IT treated as two completely separate things? Because that separation isn't just bureaucracy. It's fundamentally vital for project success.
Let's start right there then, because I think for a lot of people, IM and IT are just, vague terms for the computer department. But this requirement, it forces a real split between the two. So information management, IM, that's all about the content.
Exactly. It's the governance.
Yeah.
It ensures that all the data, all the documents, all that priceless knowledge is complete, consistent, and actually fit for purpose when it's handed over.
And it has to manage two different types of information, which is a detail that I think gets missed all the time.
It does. It gets missed all the time. And they have two totally different futures.
So what are those two categories?
Okay, so first you have the document. This is, the traditional stuff a person can read. It's structured to be stored or printed as a whole thing. So think general arrangement drawings, specs, vendor manuals, usually PDFs. These all go into the electronic document management system, the EDMS.
The big digital filing cabinet for all of the paperwork, basically.
Yeah, but a very, very sophisticated one. And the second category is pure data. This is the raw stuff. Numerical, structured information that's really only for computer processing. We're talking spare parts lists, corrosion loop IDs, all that specific tag and equipment data. And this data, this is crucial. It's destined for the big operational applications, things like the computerized maintenance management system, the CMMS that runs the plant once it's live.
Okay, so that split is the key strategic insight. Documents go to the EDMS for people to read, and data goes to the CMMS for software to process. That means the contractor is basically serving two different clients with two very different needs.
Exactly right. And the document recognizes this immediately by demanding specialized, dedicated roles. It's not enough to have a general IT guy. You need document controllers, you need data controllers, and an overall IM lead. Data control is its own specific job.
So if IM is the strategy for the content, the knowledge, where does IT fit in?
IT is defined as the key enabler. It's the infrastructure, the secure delivery system, the physical and virtual pipes that make sure all those documents and data points can actually flow securely between everyone.
All right, let's zoom in on the IM side of things then. Section 2 lays out these requirements that feel less like guidelines and more like a digital constitution for the project. It says everything, and that includes data from every single vendor and subcontractor has to align with the employer's master specs.
And that point is absolutely critical. If the employer hasn't already defined the standard, the contractor has to develop it with them in consultation. It's a partnership to guarantee that everything will, talk to each other later. You don't want a million documents in a million different formats.
And it goes even deeper. It mandates adherence to 7 specific information specifications. This is where you can really see the strategy.
Oh, yeah. If you look at those 7, they're perfectly organized to serve the 2 project phases, building it and running it long term. You've got 4 specs for the content itself, 1 for engineering documents, 1 for engineering data, then 1 for O&M operations and maintenance documents, and 1 for O&M data.
So those 4 force the contractor to think differently about information based on when it's needed, engineering versus O&M, and how it's going to be used as a document or as data.
Yeah.
They are thinking about the final handover from day one.
That's it, precisely. And the other 3 specs are all about the delivery. They are the exchange agreements with the employer. So 1 for exchanging engineering info, 1 for O&M, and 1 for the final handover. It guarantees consistency.
Okay, what about the EDMS itself, the electronic document management system? This thing has to be the central nerve center. It stores issues, tracks everything.
Yeah.
What surprised me was the depth of what has to go in there. It's not just drawings. It's all correspondence, all meeting minutes, all reports, and get this, the full record of the employer's comments on every single document.
That's the digital audit trail. It has to be complete. Every decision, every revision, all of it. And the functions it needs go way beyond just storage. For project control, the EDMS has to actively feed information into the planning and progress systems.
Okay, so what's the real challenge there? I mean, it sounds great. The EDMS automatically tells the planning software that a document is late. But how often does that automated link actually work in the real world?
That integration is one of the single biggest challenges on these projects. You're trying to link two totally different beasts, an EDMS on one side and a scheduling tool like Primavera on the other. The requirement demands a formal automated interface, which means a big investment in custom APIs or middleware to get them talking in real time. Without it, delay reporting is just guesswork.
That makes a ton of sense. And of course, the security is tight. You have to manage different renditions like the original CAD file versus a stamped PDF and control who gets to see what.
Data integrity is everything, because that brings us to the most crucial part of this whole thing, linking all of that information to the physical asset itself.
Right, and this is where we pivot from construction management to thinking about long-term operations. The requirement for the tag register is intense. It demands updates every 6 months, and then a final one 6 months before the first ready for startup, or RFSU.
That 6-month lead time before RFSU is completely non-negotiable. The operations team needs that data to start building out their systems. But the real killer detail is the depth of the tagging. The rule says all plant and equipment must be tagged down to the lowest maintainable item.
That is just a staggering level of detail. So
Plus-
you're not just tagging the giant pump, you're tagging the little bits inside it that might actually need to be replaced. Why does that one tiny lowest level item matter so much down the road?
Because if that tiny critical component isn't tagged and linked in the system, then to the maintenance team it doesn't exist. Think about a complex pressure relief valve, part of a much bigger system. If the big assembly is tagged, but the special seal inside it isn't with its unique part number and maintenance procedure, then 5 years later when that seal fails, the maintenance crew is just staring at it. They have no digital record telling them exactly what part to order or how to install it. They're blind.
So a missing tag on a tiny part could cause a huge, expensive, maybe even dangerous delay. And it's not enough just to have the tags. The contractor has to keep this master spreadsheet linking every single document to its corresponding asset tag down to that lowest level. That spreadsheet is literally the instruction manual for the living, breathing asset.
That's right. So IM defines the strategy and structures the knowledge. But that knowledge is worthless if you can't get to it or if it gets compromised. And that brings us perfectly to Section 3, the requirements for information technology. The secure machinery that delivers and protects all of this.
And the IT plan's scope is just massive. It has to cover the secure deployment of all infrastructure, ensuring everyone can coordinate, often across dozens of companies and countries.
And security is, without a doubt, the main focus. The document details multiple specific layers of defense. It starts with the basics, access control, user IDs, passwords. But it gets very technical, very fast. It demands robust protection systems.
We're talking way more than just standard antivirus software here, right?
Oh, much more. They require the latest virus definitions, a serious internet firewall, and specialized tools. Things like network access control, or NAC, which checks a device before it's even allowed on the network, or an intrusion prevention system, an IPS, to stop threats in real time. And everything, all security patches must come from a central update server. No exceptions.
And accountability is built right in. The employer has the right to audit the contractor's security at any time. It's like saying, you're holding our digital crown jewels, and we're going to check the locks whenever we want.
That audit right is a powerful tool. But the real high-stakes part of the IT section is the planning for business continuity and disaster recovery. The IT plans have to address some really specific and, frankly, extreme scenarios.
Yeah, I saw that. They cover the obvious things, like a system failure or a virus. But they also require a plan for the failure of other infrastructure, like the power grid. And the most incredible one to me was planning for the loss of operating knowledge and expertise due to a natural disaster, like an earthquake.
That one requirement changes everything, doesn't it? It implies that the digital record, the IM deliverables, has to be so complete and so well structured that you could lose your entire original operating staff. And a brand new team could, in theory, come in and operate the facility safely, relying only on the digital systems and records.
The documentation itself becomes a form of insurance against a catastrophic loss of people.
Yeah.
That's profound.
And the physical infrastructure has to back that up. All critical systems, servers, routers, workstations must have an uninterruptible power supply, a UPS. That's not for convenience. It's to ensure an orderly shutdown to prevent data corruption, to preserve the integrity of all that IM content.
So looking at the whole digital environment, it mandates a single data network, LANs and WANs, that integrates all the information systems. And this network has to support a huge list of tools from video conferencing all the way to specific applications for 3D modeling and system completion.
And there's a vital access rule in there that really highlights the security mindset. Even if the contractor is hosting everything, access to the employer's segregated part of the network is for employer staff only. It's usually done with a secure remote login to keep the systems from ever touching each other directly.
Okay, and finally, there's the tracking system for all this tech, the project applications, and system register.
This register is the single source of truth for all the software on the project. It's a digital census. It tracks the app name, the version, the supplier, how you access it, like a network license or standalone, who uses it, and a really important one, whether the employer already uses it.
Why is that last part so critical? Whether the employer uses it or not?
Because it's all about long-term compatibility and cost. If the contractor uses some obscure piece of software that the owner doesn't have, the owner now has to either buy licenses and train their people on it, or pay to have all that data converted to a format they can use. This register makes that whole conversation happen early, not as a nasty surprise at the end.
So let's bring this all together for our listener. How do we summarize this strategic split?
I think the document shows us that IM is the strategic governance. It's about the content, the structure, and linking knowledge to the physical world. And IT is the tactical execution. It's the delivery mechanism, the security, the continuity planning. It's making sure the systems holding all that knowledge never, ever fail.
Right. So the aha moment is that the reliable long-term operation of some complex facility depends almost entirely on the quality and security of the data created while building it, all the way down to that lowest maintainable item we talked about. The digital asset is just as real as the physical one.
Absolutely. The whole point of this massive framework is to tag every component and link every document to prevent failures years down the road. And that brings the whole conversation back to that tagging requirement.
We talked about the need to tag the lowest maintainable item, because here's something to think about. What if the most complex of those items, a $50 component that needs hyper-specific data to maintain, gets missed? It's untagged. What's the real cost when that one small undocumented part fails 20 years into the life of a multi-billion-dollar asset? That's the hidden value of getting this right.
If you're interested in the templates, please visit our shop. The link is in the description.
Thanks for watching. Please subscribe and see next time.